Hello, Integrated Math 1. Welcome to Module 2, Topic 2, Lesson 1, Part B. We're on the second day. We're finishing up what we started last time. So if you recall last time, so when we did our getting started lesson in class last time, pardon me, remember how you built an equation from x equals 2? And we all ended up building different equations, but you started off with x equals 2. Now we're going to do something similar in these activities, but a bit of a simplified version. Hang on. So we're actually, in this activity, we're going to build equations from two mathematical sentences, and we're going to compare our results a little bit. Now these ones that we're dealing with today, our mathematical sentences today, are going to look a little bit different from the x equals 2, and you'll see what I mean here. So if you're on page M2-101, on number 1, I'd like you to consider the mathematical sentence 2 equals 2. Okay. Is there any variable or constant that you could add, subtract, multiply, or divide to both sides? Remember, properties of equality. You could add, subtract, multiply, or divide to both sides using the properties of equality that would make this true sentence, 2 does equal 2, false. Is there any of these properties of equality, add, subtract, multiply, divide, that you could do to this equation that would make it false? So take a few moments here, choose some variables, maybe some constants, so you can add on some x's or multiply by some 5s, whatever you want to do. Create a few new mathematical sentences to prove your decision. Can you make this true statement using our properties of inequality? Can you make this true statement false? Come up with some new equations for me and see what you can do with it. Go ahead and hit pause, play with that, and then hit play when you're ready to check your stuff. So starting off with 2 equals 2, I know that's true. Of course, 2 equals 2. I know that's true. Can I use properties of equality to make it false? So how about if I use the multiplication property of equality? I'm going to multiply both sides by x. So I end up with 2x equals 2x. That is still true. That does not make it false, does it? What if I use maybe addition property of equality? So I'm going to add 5 to both sides. So 2x plus 5 equals 2x plus 5. That's still totally true. Of course it's still true. Because I have to do the same thing to both sides of these properties of equalities, I can't make it false. There is no variable or constant that I can add, subtract, multiply, or divide to both sides to make this sentence false. If I'm following the properties of equality, this sentence is always, always, always true, no matter what I do. If I'm using those properties of equality, since I have to do it to both sides, it's always going to be true. All right, with that in mind, since 2 equals 2 is always going to be true, and there isn't any way I can change that, what about a mathematical sentence like 2 equals 3? So consider the mathematical sentence 2 equals 3. You and I know that's not true. We know 2 does not equal 3. That's just not true. But let's give it some thought like we did last time. Is there any variable or constant you could add, subtract, multiply, or divide to both sides using the properties of equality to make this false sentence true? So we know this is false. Can you use the properties of equality to make it true? So again, choose variables and constants to create new mathematical sentences to justify your conclusion. So yeah, play around with that. Go ahead and hit pause, play with it, jot down your thoughts, and then hit play when you're ready to check your work. So I busted out with my 2 equals 3. I busted out a few things. I was like, well, what if I use some addition property and I'll add x to both sides? 2 plus x equals 3 plus x. That's still not true since x is the same thing. Maybe I'll then use multiplication property and I'll multiply both sides by 5. You probably did something different with yours. It's okay. But even if I take that and multiply it by 5 and I take the 3 plus x and multiply that by 5, they're still not equal to each other. It's not going to give me the same answer. So there is no variable or constant that I can add, subtract, multiply, or divide to both sides to make the sentence true. If I follow the properties of equality, the sentence is always false. 2 will never equal 3. Those properties of equality aren't going to change that no matter how hard I try. But this leads us to an interesting thought, and I want to point something out here. There's a reason why I made you do this. You guys know 2 equals 2. You know 2 doesn't equal 3. You know that. So why did I make you do this? There's a reason. A linear equation, so we have all these linear equations. It's what we've been solving. But the deal is that it doesn't have to have a solution. A linear equation can have one solution, which last time, that's what we encountered, right? On our last lesson, our last day that we were working together, we kept getting one answer, one answer, one answer. We found x equals this, x equals that, x equals this. So linear equation can have one solution, just like we're used to, like we've been doing, but a linear equation can also have no solution at all, or it could even have infinite solutions. So the equations that you solved last time, that we solved in our previous activity in 1.1 in the last class, those are all examples of linear equations with one solution, right? X equals 5, x equals -6, x equals 15 halves. Those are all examples of linear equations with one solution. We found that one solution. A linear equation, and this is where it gets critical here, so I hope you're like highlighting this. Notice that it's bold. Notice these are our key terms. A linear equation with no solution means that there is no value for the variable that makes that equation true. If there is no way that thing could possibly be true, if it's always going to be false, we're like, then it has no solution. Pardon my cat going crazy in the background. A linear equation with infinite solutions means that any value for the variable makes the equation true. So if there's no way it could possibly ever be true, we say it's no solution. That's not true. That's never going to be true. There's no solution. If we're like, oh, but it's always true. Those are always equal to each other. Doesn't matter what I plug in for x. Then that's when we say we have an infinite solutions. There's infinite number of possibilities. X can be anything it wants. It doesn't matter. It's always going to be true. So with this in mind, I would like you to go back and look at those equations from the activity. So the equation in question 1, we'll start with that one. So for part A, I want you to explain whether the equations you created in question 1, so same page, 102, up on question 1, does that equation, those equations that we made there, do they have one solution, no solutions, or infinite solutions? Go ahead and hit pause, jot down your thoughts, and then hit play when you're ready to check your work. So that first question, that was the 2 equals 2. And like I also had 2x equals 2x, and then I had 2x plus 5 equals 2x plus 5. That's always true. 2 always equals 2. It's always true, no matter what I do for x. Even if I did 2x equals 2x, it doesn't matter what I plug in for x. It's always true. So we say that it has infinite solutions. So that's my clue. Let me bring out my pen here. So because this is always true, I lost my pen. There I am. So because this is always true, oopsie, then that's when I'm like, hey, that has infinite solutions. Could be anything. What about then for part B, question 2? So question 2 in this activity, higher up on the page, explain whether the equations you created in question 2 have one solution, no solution, infinite solutions. Tell me what you got there. Go ahead and hit pause, write down your thoughts, and then hit play when you're ready to check your work. So that was the one where we had 2 equals 3, and I like added some junk to it and multiplied by 5. It doesn't matter. 2 will never equal 3. 2 will never equal 3. It's just not how the universe works here, people. So because this guy is never true, that is false. That is never true. That's when I say, well, then there is no solution. So the fact that this is never true, 2 never equals 3, that means there's no solution. All right, now I'm going to mess with you a little bit. I'm going to mess with you just a little bit. Question number 4. Consider the equation 2x equals 3x. Does this equation have one solution, like x equals something? Does it have no solution, because it's false? Or does it have infinite solutions because it's always, always true? Explain your reasoning on this and maybe show some work if we need to. Go ahead and hit pause, jot down your thoughts on this, and then hit play when you're ready to check your work. Charlotte wants to join in on the fun. So 2x equals 3x. So here's what I did. I solved it. I was like, well, let me get the x all alone. I decided to get x all alone to solve it just like we did, just like we usually do, see what I can do here. So I subtracted 3x from both sides. Sorry, my cat really is, she's got a case of the zoomies back here. So I subtracted 3x from both sides. 3x minus 3x, of course, gives me 0, and 2x minus 3x gives me negative 1x. So I use my subtraction property of equality. Now let's get x all alone, but it's being multiplied by a negative 1. So I'm going to use the division property of equality and divide both sides by a negative 1. The negative 1 divided by negative 1 will cancel themselves out, so I just have x over here. And 0 divided by negative 1 is, well, 0. 0 divided by anything is 0. I got x equals 0. That's right. This equation has one solution. I was able to solve for x. Because I was able to solve for x, I have one solution. I was able to say, hey, x equals 0, which is true, right? If I plugged in a 0, 2 times 0 is 0, 3 times 0 is 0, 0 equals 0, that would definitely be a solution that would make this statement true. Definitely. So it's interesting. If I can solve it out and find out what x equals, then I have one solution. If I try to solve it and I end up with something like 2 equals 2, that's always true, then it has infinite solutions. But if I solve it and I end up with something like 2 equals 3, and I'm like, that's never true, then I say there's no solution. So with that in mind, this problem is not in your book. It's not in your book. But you might want to find either some space in your book or maybe find some paper somewhere that you can work separately. I would like you to determine if each equation has one solution, no solution, or infinite solutions. And you're going to have to show your work. So that means you're going to need to solve it, okay? You're going to need to actually solve these, work these out, and see what you discover. Go ahead and hit pause, work all these out, and then decide if they have one solution, no solution, or infinite solutions. Then go ahead and hit play to check your work. All right, so I'll start off with this guy. I'm going to do some distributive property because I hate all of those parentheses. So I'm going to do some distribution, so negative 2x, and that would make that a positive 6, and then negative 6x, and that would make that a negative 6. So I'll just do some distributive property. So now I have negative 2x plus 6 plus 5, negative 6x minus 6 plus 4x. Sorry, the colors went weird. I tried to color coordinate it, and my computer just went funky. Yay. I do see that I have some like terms here, so I'm going to go ahead and add up 6 and 5 gives me 11. I also have a negative 6x and a positive 4x, which will give me a negative 2x. So this is now negative 2x plus 11. These guys combine up to make a negative 2x, and then I have a minus 6. I have x's on both sides. We don't like that, so I'm going to kill one of them off. Since that's a minus 2x, I'm going to go ahead and add 2x to both sides. But something interesting happens here. Because it killed that guy off, but it also killed that guy off. And so I ended up with 11 equals negative 6. Well, that's never true. 11 does not equal negative 6. I'd much rather have $11 than negative 6. Oh, somebody $6. Not good. So because that's not true, and it's never true, then I'm going to say no solution. All right. Let's come on over here to this guy. If this one was freaking you out, I'm not going to lie, it was freaking me out a little bit too, mainly because of all those fractions. But I noticed all those fractions had a denominator of 2, that everything was getting divided by 2. So I thought, maybe if I multiply everything by 2, it'll kill it off. So I decided to use the multiplication property of equality, and I'm just going to multiply both sides by 2. At this point, I have to distribute. So if I multiply 2 times this first term, the 2's cancel out. And then, of course, 2 times 6 is 12. I have to distribute over here. So 2 times this first term, well, 2 times a half is 1, so that kills itself off. And then, of course, if I do 2 times 17 halves, the 2's will cancel, and I will just have 17. So when I multiplied 2 with the first term, the 2's canceled out. I just had 3x plus 1. 2 times 6 gave me 12. Over here, I did 2 times a half. That canceled out and left me with that 3x minus 7. And then 2 times 17 halves, well, the 2's canceled out, and I was just left with a 17. We do need to clean it up a little bit, though. I've got some like terms here. 1 plus 12, of course, is 13. Negative 4 plus 17 is also 13, so I'll clean it up a bit. Oh, sorry, my little underlining is in the way. Go away. Next up, I have x's on both sides. I don't like that, so I'm going to go ahead and eliminate one of them. I'm going to kill one of them off. Well, that's a positive 3x, so I'm going to go ahead and subtract 3x from both sides. But 3x minus 3x is 0, and 3x minus 3x is 0 again, so they canceled out on both sides, which means I just have 13 equals 13. Well, 13 always equals 13. That's always true, which means there's an infinite number of solutions here. It doesn't matter what I plug in for x. It's always going to be true. So x can be anything. Infinite possibilities. So I'll say it has infinite solutions. Let's take a look at what's going on over here with this third equation. I'm going to go ahead and distribute. I don't like those parentheses. So negative 2 times x is negative 2x, and negative 2 times 10 is negative 20. And I have to distribute that negative as well. I got to do distributive property again. You could think of that as a negative 1 if you like. You don't have to, but I'm going to put a little 1. Ooh, that didn't work so well. I'm going to put a little 1 in there. So negative 1 times 5 is negative 5, and negative 1 times negative 2x is a positive. That should be a 2. Typos. Hang on. I'm going to fix my typo. And Charlotte's angry too because I made a mistake. Oh my goodness. I made a mistake and it affected everything else. No, that's terrible. I made a mistake. Oh my gosh. So much fixing I have to do now. It's all right, guys. It's okay. Nobody panic. Maybe panic a little bit because it was a big, fat, ugly mistake. See, nobody's perfect, including your math teacher. I can't type things right. That's not good either. Thank you for your patience. Will I fix all of this? All right. There we go. Sorry. Coming back. There we go. All right, hang on. There we go. All right. We'll put these guys back where they belong. All right, so now I've distributed, and I've distributed correctly. Yay! Theoretically, so I have -5 plus 2x. Sorry about the mistake. Oh my gosh. See, nobody's perfect. Aren't you glad to know that? So that means, though, that I have 20x minus 2x, which gives me 18x. And I went ahead and switched these. I used the commutative property. Instead of -5 plus 2x, I did 2x minus 5. It just looks better. You don't have to, but it looks better. I have x's on both sides. So I'm going to go ahead and subtract 2x from both sides. So minus 2x, yay. Which means, of course, 2x minus 2x is 0. So that's going to cancel out, only if my pen comes back. There we go. So 2x minus 2x, 2. So, of course, 18x minus 2x is 16x minus 20. And of course, we still have a -5 over there, so it equals -5. Let's go ahead and add 20 to both sides. It'll make things easier. So plus 20 plus 20. Of course, a -20 plus 20 is nothing. They cancel out, which is why we did it. And -5 plus 20 gives me a positive 15. 16x equals 15. Well, then let's divide both sides by 16, and I get x equals 15 over 16. I got an answer. I mean, it's a funny looking answer. It's kind of a weird answer, but it is an answer. So that means I have one solution, because that's the only thing I could plug in for x that would make this original statement true. True story. All right, guys. As always, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, please feel free to let me know. Come talk to me. Hey, stick around after class. Come see me during office hours. That's what these things are for, you know. And I'll see you later. Bye.